sophomores, and we're all from Aspen High School. But to start, I'm Steph Wojcik.
Hi, I'm Kylie Kenny.
Hi, I'm Connor Gagan.
I'm George Beck.
I'm Annika Nichols.
I'm James Kelly.
I'm Darren Hunting.
I'm Alex Martin.
I'm Emily Kitty.
Hi, I'm Daniel Garzetti. I'm Harry Wilson.
Okay, and we're here today to present you water chemistry in our watershed. These are some fun gifts for you. They're very entertaining.
Okay, so to start off, we're going to be doing hydrology.
Yeah, sorry. So hydrology is the study of circulation, distribution of water above and below the Earth's surface and also in the atmosphere.
Okay, so to start off, when we're talking about hydrology, that's typically measured in CFS, which is cubic feet per second, and 1 CFS is approximately the size of a basketball. So when we're discussing CFS, we're basically talking about how many basketballs are flowing through a certain area per second.
So the places where we got water samples are grottos, North Star Preserve, Heron Park, below the frying pan, below Slaughterhouse, and also above Glenwood, so West End. So just so you have a visualization, the grottos are at the bottom here, then moving up we have North Star, then Slaughterhouse, then frying pan, Crystal River, and then Glenwood Springs. Then also here's an example of North Star Preserve, and that's this girl right here jumping in.
So this is the measure of CFS in peak season, and it also shows the months per year ranging from 2015 to 2018. And as you can see, the 2018 peak was significantly lower than the peaks years before. So the 2018 peak was 3,000 CFS, and the 2015 peak was 8,000 CFS. So as you can tell, this is a dramatic drop in CFS at the same time of year. And this also shows, so starting at the grottos, as you can tell, the CFS is significantly lower than the CFS at West Bank as you're heading towards Glenwood, because as you go down river, naturally there's more tributaries and smaller rivers flowing into the Roaring Fork River. So you might be wondering, why is this significant to us as people and citizens of the Roaring Fork Valley? And the 2018 was a major drought year for us, and this has not only an impact on the Roaring Fork Valley or on Colorado, but on so many other states, because the Roaring Fork Valley flows into the Colorado River, and the Colorado River supplies water to so many different states. So if there's not enough water or below average water in our river systems, then there's not enough water for people to perform their daily activities, which also means that concentrated pollutants and ions in the river, they get more concentrated, and this is bad because not only are people receiving less water, and animals as well, but they're receiving worse, like more polluted and more concentrated bad water.
Along with that, the aquatic life is also affected by that, so all species that are living in the water then have less healthy water to create an ecosystem off of, which is a negative aspect, and then can also lead into what Kylie was talking about affecting the people and the rest of the valley. And that is hydrology for you. There you go.
Next, we will be discussing location on the Roaring Fork River versus alkalinity. What is alkalinity?
So, in simple, alkalinity is the water's ability to neutralize an acid, and this is known as its buffering capacity. And this is measured in is the amount of carbonate and bicarbonate in the water. So you might also wonder, why is alkalinity applicable to us? So alkalinity is important because if water becomes too acidic, then aquatic life cannot survive. So let's say it's acid raining out and there's a low alkalinity lake. When this acid rain goes into the water, it drops the pH below an acceptable range, and the aquatic life can die. Whereas if a lake has a higher alkalinity, it can then neutralize this acid rain and allow the aquatic life to survive.
So how is alkalinity measured? Alkalinity is measured by completing a titration using sulfuric acid and a phenolphthalein indicator. During the titration, the solution would react differently, and you would have a different series of steps depending on how the solution reacted to the sulfuric acid. But the overall goal of it is to reach a pH of 4.2, because at this point all of the alkaline components in the water have been neutralized, and you would record the amount of sulfuric acid needed to reach this point, and that would be your alkalinity measurement. This is the sample. This is our graph. And as you can see, it trends upwards for the majority of the river, and it has a slight pause between the North Star Preserve and Heron Park. And this is most likely due to the close proximity of these two areas. They're probably maybe like 2 miles apart, and there's not much change in the soil or pollutants that enter the water at those points.
So in conclusion, the alkalinity in our watershed tend to trend upwards, and this is good because it allows the water to adapt to changes in pH, which allow the aquatic life to survive. We also noticed that the phenolphthalein alkalinity was at 0 with the exception of Glenwood, and the only way we could really, so then we had some questions. We wondered if the trend of continuing upward would continue farther past Glenwood, where we ended our measurements, and if the phenolphthalein alkalinity will remain at 0 and just have Glenwood be an exception, or if it will then rise.
That's all for alkalinity.
Okay, so next up is hardness, and water hardness is the total concentration of magnesium and calcium ions in water. And generally, the higher hardness in the water, the better, because calcium is a nutrient for plants and animals in the river. Okay, so why is it important? Fish culture heavily relies on water hardness, because water hardness generally, it goes hand in hand with calcium, and calcium is important for the development of fish. For example, it helps with bone development, and it helps prevent blood clotting. And it also protects fish from heavy metals, because instead of absorbing the heavy metals, the fish will instead absorb the calcium, and this is just beneficial.
Okay, so as mentioned before, as a whole grade, we went and collected water samples from different locations, and we used the titration system as well to figure out what the levels of, what the parts per million of each different sample were. So our class, we measured the hardness at Heron Park, which was 70 parts per million. Other locations where we got data included the Grottoes Bridge, which had 136 parts per million. North Star Nature Preserve, which had 50 parts per million. Below Aspen Slaughterhouse, which had 220 parts per million. Below the frying pan in basalt with 248 parts per million. And at West Bank above the Glenwood with 280 parts per million. Okay, so in conclusion, we live in a town supported by tourism. We heavily rely on fishing, rafting, and more. And the #1 industry affected by water hardness is the fishing industry. Calcium levels that are what affect the levels of biodiversity in the water, as well as how safe the water is for other uses like drinking, so that affects us. From our results, the most hard and best areas were Slaughterhouse, the frying pan, and West Bank, because they had the highest level of parts per million. Next was the Grotto Grottoes, where we tested Heron Park, and the softest was North Star.
So we will talk about pH, and this is our research question, that how does the pH level of the roaring fork watershed change as it flows from the independent ponds towards groundwater?
So in order to answer our research question, we must first determine what pH is. And pH is the negative logarithm of the concentration of hydrogen ions in a given liquid, or basically how acidic any sort of liquid is. So it is measured on the pH scale, with 1 being the most acidic, 14 being basic, and 7 being neutral. You can see here that we have how organisms respond to different levels of pH. So at 3.5, all fish die, and at 9.5, all fish die, and anything in between, some life can be sustained. The Colorado standard is 6.5 to 9 pH for a healthy river.
So, pH is influenced by a lot of different factors. Some of the main ones are photosynthesis being formed by various plant life in the water, like algae, the amount of ions in the water, different animals in the water breathing, and also the decomposition of various animals that die in the water. Also, pH is also affected by the types of rock or soil in the water as they erode. And then more factors would be like pollution, so drainage from mines and factories, or acid rain is a big factor, which comes from an increase in carbon dioxide levels in the atmosphere.
And so pH is especially important with river health because it can be extremely harmful to aquatic life. Colorado standard is between 6.5 and 9, as it becomes dangerous to aquatic life below 5.0 and 9.0. And this is because it's especially harmful to young fish and insects, as too high or low pH levels become corrosive to their skin, as well as the hydrogen ions in pH can combine with bicarbonates and carbonates, which are stealing them away from insects and fish, as they're incredibly important with building skeletal structures. And it also aids the release of heavy metals as it raises their solubility, and with that it fills the river with heavy metals. And mine drainage can combine with hydrogen ions to create sulfuric acid and other byproducts which are incredibly harmful to river health.
Okay. So how do we collect pH? This group specifically, we measured the Heron Park sample. At the time, when we got the sample, it was 8 degrees Celsius. And measuring pH, we used a pH meter, and we calibrated it with known pHs, being that of 8 and 6, because we expected it to be somewhere in between. And we got 7.88 pH, which is reasonable for fish to live in all aquatic life.
So this is the data we got for all of our different measuring points in terms of pH. And so some trends we noticed with the data were the earliest point we got our pH measured, and the lowest point we got our pH measured were both are basically 7.5. And it also, another trend we noticed is that once the pH hits a town, say Aspen, so like Grottoes Bridge and North Star are above Aspen. Once we hit Aspen at Heron Park, that's the highest pH we found, and then pretty much after Aspen, the pH starts to decline again.
My conclusion is Heron Park is generally healthy at a pH of like 7 through 8, and that's what we got, so all aquatic life should be fine. And reasons that Heron Park might have had a higher pH would be from either tributaries joining the river with different pH levels,
or rocks and or soil around it or in it. And we can conclude that as as the river goes downwards, pH also goes downwards. But like when we measured it at the grottos, it was at a low because of mine drainage possibly. But besides that, we can probably conclude that as the river goes down, pH will also go down. Yeah.
Does anybody have any questions? We're here to answer any of us for any subject that we covered. If anybody has any questions, hopefully not on this slide, but maybe something else.
Yeah, we've been doing a lot of talking, so I'm kind of curious. Do any of you guys have anything you'd like to share? Comments, concerns? Anything?
Any questions? All right, we can come back to anything that comes up in our discussions. Oh, okay. Sorry. Yes.
Go ahead.
So I was a little confused as to there was another group that had the same topic, and I'm pretty sure they got some different answers than you guys. So
That is very interesting. Do you know what school they were from? From Aspen as well? It was them sitting in front of you?
yeah, I think so.
Anybody have anything to say?
Why don't you guys, at our discussion, we'll have a couple of minutes at the end, and that could be something that we come back to, the two different groups who have different numbers. Chat with each other then, and maybe we'll report back on that. Does that sound good? Okay, so we're going to have the restaurant group come up next, so we can stay